Lightning is one of nature's most powerful and awe-inspiring phenomena. A sudden flash of blinding light, followed by the deep rumble of thunder, can be both beautiful and terrifying. But behind that dramatic display lies some fascinating science. So, why does lightning happen? Let's break it down step by step. Lightning begins inside large storm clouds called cumulonimbus clouds. These clouds can stretch miles into the sky and hold billions of water droplets and ice particles. Inside them, powerful updrafts and downdrafts move air, ice, and water around at high speeds, creating collisions between particles. When ice crystals and water droplets collide, they exchange tiny electric charges. Lighter particles, like small ice crystals, tend to gain a positive charge and are carried to the top of the cloud by updrafts. Heavier particles, like hailstones, usually become negatively charged and sink to the bottom. This movement creates a giant electrical imbalance inside the cloud. Over time, this process creates a strong electrical field. The top of the cloud is positively charged, while the bottom becomes negatively charged. The ground beneath the storm also starts to respond. The negative charge at the cloud's base pushes electrons in the ground deeper down, leaving the surface of the Earth positively charged. This setup is like charging a giant natural battery in the sky, with the cloud and the ground holding opposite charges. When the electrical difference between the cloud and the ground, or even between parts of the cloud itself, becomes too great, nature looks for a way to balance it out. This is when lightning strikes. Lightning is essentially a massive electrical discharge. It usually starts with something called a stepped leader, a faint, invisible path of negative charge that snakes downward from the cloud toward the ground in steps. As it gets closer, positive charges from the ground race upward to meet it, often from tall objects like trees, buildings, or even people. The moment these opposite charges connect, a powerful surge of electricity flows, and that's the bright lightning bolt we see. This entire process happens in a fraction of a second. Lightning is incredibly powerful. A typical bolt carries about 300 million volts of electricity and can heat the surrounding air to 30,000 kelvins. That's about 5 times hotter than the surface of the sun. The sudden heating makes the air expand explosively, and this rapid expansion creates the sound wave we know as thunder. Not all lightning looks the same. There are several types, including cloud-to-ground lightning, the classic bolt that strikes the earth; intercloud lightning, flashes that happen inside a single cloud, which often light up the whole sky; cloud-to-cloud lightning, bolts that jump between separate clouds; sheet lightning, when the flash is hidden by clouds, making the sky glow; ball lightning, rare, a mysterious, glowing orb of energy that scientists are still trying to fully understand. Many may also wonder, why do we see lightning before hearing thunder? Light travels much faster than sound. Lightning is visible almost instantly, but thunder takes time to reach us. This is why you can count the seconds between the flash and the rumble to estimate how far away the storm is, roughly 5 seconds per mile, or 3 seconds per kilometer. So, why does lightning happen? It all comes down to electrical imbalances created inside massive storm clouds. When those charges get strong enough, they're released in a spectacular burst of energy that lights up the sky. It's nature's way of balancing its electrical accounts, and a reminder of just how powerful our atmosphere can be. Thank you for watching. Please like and subscribe for more.